Hi, Mr. McTaggart here, and this is the last video in my series of angles in a circle. We're literally just going to look at exam paper questions. So what I've done is I've selected several questions from the exams. I've condensed them a wee bit without all the writing, and we're just going to work through them, and I'll talk you through the methods to get the answers. These don't include angles in a polygon. I've saved that for a separate video, so this is just angles in triangles and circles. So example 1, it's asking us to find angle ONM. Now I've had to tilt this picture a wee bit to get it to fit a wee bit, and then also remember my tip that I always say is try and rotate the picture so that the circle's on the ground. So if you have a look at my letters, they don't quite look like ONs and Ps, but this question was originally presented like this in the exam. So my top tip was always, right, when it's presented like that, spin it so that you're looking at it, that you have the wheel sitting on the ground. It just makes it a wee bit more obvious for that 90 degrees to jump out where your radius meets the tangent. So here's your radius, here's your tangent, so I know that that is a 90 degrees in there, okay? Now, top tip next was always look for radiuses. So this line is a radius, this line is a radius, this line is also a radius, but it's not part of an isosceles triangle, so I don't put that one in. Now I'm ready to start the question and get some missing angles. Now they're after angle ONM. Sometimes in the exam they mark it, which they have in this case. They've shaded it in grey, but they don't always. It's to test that you know what angle ONM stands for. So remember, O to N to M is a pathway, and you're always looking for the middle letter. The middle letter is the angle that you're actually after. So we're after angle N, okay, which looks a bit like a Z because remember I've spun my picture. So all we've been told is that this angle down the bottom corner is 14. Now I have a big right angle triangle going on here. I'm just going to trace it with my pen. So we have this right angle triangle here that we're going to focus on first of all. So we do 90 plus 14, which is 104. And that means that the missing angle at the top of this triangle at O is 180. Take away 104, which is 76. So this angle here is 76. Now the angle beside it here is on a straight line, so it is 180 take away 76. We've just done the reverse of that sum, so we know that this is 104. Now these two angles that are shaded and this one down here are matching, they're part of your isosceles triangle. So you go back and you do 180 take away 104 again, which brings back this 76. So these two angles are half of 76. And if you don't know half is 76, remember you can do a little old sum, it's 38. So these two angles in here are 38. Now, if I do this in the exam, I found the angle I'm after, but I don't necessarily get full marks here. You have to conclude the question and make sure you get your guaranteed marks is finish it off and actually somewhere on your page state what the angle is. So you're going to write the angle, I'm just going to fit it in here, angle ONM equals 38 degrees. So please, 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 once you think you've got your angle, state it somewhere explicitly next to the question, highlight it, underline it, so that we can see you knew that it was angle ONM you were going to get, okay? That's my top tip. Right, let's look at another one. This one's a wee bit different. It's got some arrows in it. So remember what these arrows mean. They mean you've got parallel lines, and it would tell you that within all the wording of the question. We're after angle ABC, so again, they have highlighted it in grey, that we're after this angle here. Now, the year I marked this one, loads of folk managed to get 2 out of 3. They just couldn't get that final little bit. So the first angle we're going to go for is this one here. It is on a straight line there with the 143. So this is a straight line, so it makes 180. So 180 take away 143 makes this angle 37. Then what you've got going on here is those parallel lines tell you to look for Z and F shapes. So here is a Z shape. So if this angle is 37, so is that angle in there. So we're going to put that in, that's 37. So that would have got you your first mark. The second bit is for recognising that this bit is a radius meeting a tangent, and radiuses and tangents meet at 90 degrees. So if this is 90 degrees, this one in here is 90 take away 37. 90 take away 37 is... I've hit a wee blank moment there, is 53. So this angle is 53. And in this exam, loads of people got to here but didn't know how to get that final angle. So this line A to B and B to C, the ones that I'm just highlighting just now, are both tangents to the circle. And remember what we told you, whenever a radius meets a tangent, it meets at 90 degrees. So this is also a little 90 degrees over here. Now that little sneaky radius wasn't drawn in, I've drawn it myself. And in fact, it's made that this is actually another isosceles triangle going on over here. Because your radius meets that tangent, radius meets that tangent, you've actually formed a kite. So if you turn your head to the side, you've got a kite shape going on. So this means that this angle up here is also 53. And if you do 53 add 53, you've got 106. And 180 take away 106 is 74. So the shaded angle here is 74. But remember, you need to say the angle ABC equals 74 degrees. Highlight it somehow that we can see your conclusion to the question and you knew what angle you were finding. So Z shapes could creep in as well, and we don't normally teach that as part of it. Maybe only bring it in when we start showing you some past paper questions. So it brings in a lot of knowledge from S1, S2 or National 4. Okay, third example. This one here has an awful lot going on. This is probably my hardest example so far. So we're going to look for radiuses and right angles first of all. So let's look for radiuses. There is a radius, there is a radius, and there is another radius. So I've got two isosceles triangles. Next I'm going to look for right angles. Here is your radius meeting a tangent. So there's a right angle this side. There's also a right angle on this side. So two right angles. Now there is actually a third right angle going on. See this triangle here? This is a triangle within a semicircle. So that is a right angle triangle. So just in a different colour, I'm just going to show that this is a big old right angle going on there as well. Okay? Now, there is more than one way to go get angle CAB. So this is angle CAB down here that we're trying to get. This one that's already shaded in grey. I'm going to fill in all the angles. Now, the order that I go is not necessarily the order you might spot. And you don't need to find every single angle. So what I'm going to do is I'm going to do the way I see. And then I'll delete my answers and show you a different route and we will still get the same answer. Either way, the first one we have to get is this one that's on a 90 with 58. So 90 take away 58 is going to be 32. So this little angle in here is 32. And that makes this one over here 32 as well because they are in an isosceles triangle. 32 add 32 is 64. 180 take away 64 is 116. So this angle in here is 116. Then I'm going to do this one. It's on a straight line with 116, which is 64. Right, I have enough information now. If I just focus on this big triangle here that I'm highlighting in yellow, lots of colour going on. There is a right angle triangle. We know that it's 90 in the corner. 90 add 64 is 154. Take that away from 180, it makes my shaded angle 26 degrees. So angle CAB is 26 degrees. Notice I didn't have to fill in any of these other ones, but I'm going to go back and do it in a different method and show you that we get the same. So what I can do is if I go back to just maybe this stage here and not even put in that other 32. First step is still to get that as 32. Then I've spotted that this was a right angle, remember? So 90 take away 32 gave me 58. So this one was 58. That makes this one also 58 because it's an isosceles triangle. 58 add 58 is 116, making this angle up here 64. I can then bring back that yellow triangle I just used a second ago. I've got 64 at the top, 64 and 90 is 154, making this one 26 again. Okay, now there is another method, so let's trace back a wee step and just get back to where we put in this 58 here. This other angle here is also making 90 with 58. So this angle in here is 32. This is also 58 using isosceles triangles. And then I could do this one here is 180 take away 58, which is 122. Now I can focus on an entirely different triangle, one that I wouldn't always, but some people do. If I focus on this triangle, I've got 122 and 132, which gives me a total of 154, making this missing angle 26. So whichever way you look at this, these angles are going to give you 26. And remember your conclusion, angle CAB equals 26 degrees. This is probably the busiest and worst question, but remember you don't need to fill in every single angle, but just for the sake of it, That is what it would look like if we filled in every single angle. Okay, question 5. Here come the parallel lines again. So I'm going to highlight my little Z shape. There is a Z shape. There is also a little F shape going on. There's an F shape here. So remember, parallel lines can be F's and Z's. Right angles. We have a radius with a tangent on the ground. So we have a right angle here and we have a right angle on this side as well. We also have a triangle inside a semicircle. This ABT is a triangle inside a semicircle. So there's a right angle at B as well. Now, spotting that right angle at B allows us to get this angle in here. 90 add 40, the numbers are actually really simple on this one. 90 add 40 is 130. Don't know why my pen's not working. Which makes this one down here 50. Now, using my Z shape, this one here will also match. Using your alternate angles, that would be 50 degrees. Which gives me enough information to then find this angle down here, which is 40. And also I could have gone and got this angle here using the 90 fact and said that that was 40. And then used my F shape to get that 40. Again, there's more than one route. Now they wanted angle OPT, so this was indeed what they were after. So to conclude, angle OPT equals 40 degrees. So watch out for those F's and Z's. They only work if we give you the parallel line arrows, and it will also tell you in the question that they are parallel lines. Okay, moving on. Question 6. Now this one uses tangents and angles in right angle triangles in a semicircle. So we have a right angle at K and a right angle at J. They are both within the semicircle using the diameter as one of the sides. There is also right angles going on down here where your radius, where your radius meets your tangent. Now we are asked here to find angle KLJ. So the angle we're actually after is these two angles combined. So we have to do an old left side, right side approach and then put our answer together. So if I start with the left hand side, 90 add 31 is 121. Take that away from 180, I have 59. So this angle here is 59. Now this one on the other side of the 59, I'm going to use the fact that this is 90 down here. So I'm just going to do 90 take away 47, which is 43. So the combined angle which we are after is 59 plus 43, and 59 plus 43, if you add them together, gives you 102. So to conclude the question, angle KLJ equals 102 degrees. Okay, so that's just another wee twist, and we've actually to add two angles together. Nearly there. Moving on, question 7. Again, I think I've seen this diagram already. This is quite a busy one. We're asked to find angle QRS. So we are looking for this angle down here, which I'm just going to highlight in yellow. So this is what we are after. Right, radius. So radius. So there are two isosceles triangles again. Right angles, there is a right angle down here where your radius meets your tangent. There is also a right angle going on here, which I'm going to make giant, because that is a triangle with inside a semicircle. Q to P to S is right angled. Now the place I would start would be using this isosceles triangle. I would say that this one here is 28. 28 add 28 is 56. 180 take away 56 is 124. So this is 124, which makes the other side of that on a straight line 56. Okay, two ways to go from here. I've actually got enough information again to finish it. So if I'll just highlight the triangle I'm looking at just now for you in yellow, focusing just on this triangle, I have enough information to simply go do 90 add 56 is 146. Making my missing angle 180 take away that, which is 34. But I might not have gone that route. I might have wanted to fill in everything. 180 take away 56 is 124. Half it makes this one 62. And that one 62. And then 90 take away 62 makes this one 28. Straight line with 62 is 118. And if you add 118 and 28 together, you get 146, making this angle still 34. As always, conclude it, angle QRS equals 34 degrees. Make sure we see your nice final answer nice and clearly. Okay, nearly done. Second last one. Now this is the busiest and the worst question we've seen. We are after angle BDF. So BDF is B to D to F. This combined angle up here we're after. And there is loads going on here. So my radiuses are here, here, and here. So I've got two isosceles triangles again. My right angles are here at F because this triangle EFD is within a semicircle. So there's a 90 there. There is also a 90 here where your radius meets your tangent. So there are 90s either side. There is also another big old right angle triangle going on there as well. So loads to do, but we don't actually need to fill out that much in this one. My first angle is going to be this one here, which will be 90 take away 77. So that will be 13. Which makes this one up here also 13, okay? Then I'm going to go to triangle DEF and get this one. This is just 90 add 64 is 154, subtract give me 26. So the actual angle I'm after is 13 plus 26, which is 39 degrees. So angle BDF equals 39 degrees. Notice I didn't have to fill in all those other angles, but let's go do them anyway. So 90 take away 13 made this 77 and this 77, which gave me 154, which made this 26, this 154, and then that would have been a really long way to go get me the other 13. So we didn't actually need to fill them all in. Right, my final question before I review is this one. A lot easier than that last one. My top tip again is I'm just going to spin this one because I like my wheel to be on the ground. We're after angle EPR from the question. So EPR is this angle here. So E to P to R is what I'm after. Okay, there's no radiuses in this one, but there is a right angle triangle there because that's within a semicircle. There's also some right angles going on down here where your radius meets your tangent. So the first one I'm going to get is I'm going to focus on this big old triangle here. If this is 48 in the bottom corner, then the top one will be 48 add 90 is 138, so this top one is 42. And then if I now focus not on that yellow triangle, if I now focus on this blue triangle that I'm highlighting, if I focus on this one, 90 add 42 is 132. Take that off 180 makes this angle in here 48. So we've got 48 creeping out again. Now we know this angle on this side is 90. We wanted this combined angle. So angle EPR in conclusion is 138 degrees. This has been a long video. These are tricky, but if your mental arithmetic is there and you remember all your angle facts, you will do fine. And remember, my number one tip is make sure you conclude your question at the end. Thanks for watching. Bye bye.